Adrian,
Well,
I
yes.
will present first CIGRE and Romania, and then the presentation with the topic. Okay, so hello everyone.
Perfect.
Can you hear me?
Right now, can you see the screen?
Uh, yes, yes. Thank you, Pikria.
Okay,
Okay,
perfect.
so hello everyone. It's a great pleasure to be here today. Um, uh, s- mm, Pikria, can you let me to present our presentation to uh, okay, thanks. So since its founding in 2015, NGM Romania has grown to 90 active members, representing 17 different companies in the energy field. We are coordinated by a dedicated and diverse team, including chair, vice chair, secretary general, scientific lead, events lead, marketing lead, and coordinators for social media and membership growth. We are proud of our gender balance. 45% women and 55% men, and our age distribution, of course, under 35 years. So we can say we, we truly are the next generation. Over the past year, our team has carried a wide range of impactful activities. Um, so we
Sorry, Adrian, I think your voice might have been lost. Um,
No
excuse
worries. I
me.
can continue, Pikria, if I
Yes.
can
Okay.
reshare it.
Thank you. Just yeah. I'm sorry for the technical issue.
No worries. I can
Okay. So will
continue.
you share, or should I continue sharing?
Yeah, you can continue sharing. It's fine.
Okay. So I'm sorry for that. Okay. I think we're back.
Okay. Great. So as you see in this slide, we have plenty of activities. Our strategy was to design as many initiatives and different projects for the young energy professionals in Romania with technical expertise, the power systems field and electrical engineering field. So here are mentioned just a few of them. Obviously, one of these kind of initiatives is related with joint webinars, as is the case for this one today. We are organizing different expert talks where we are bringing senior experts from CIGRE or from the industry, where they can present in specific topics, projects, or different kind of theoretical information. We are also organizing a lot of technical visits to some of the main energy objectives in Romania, such as hydropower plants, wind parks, and so on. We developed within the CIGRE Romania National Committee the first digital magazine, which is called Volta, and it is fully organized by the NGN members, I mean the editorial team. We also have interviews both with junior and senior CIGRE members, and obviously we are highly involved in other international conferences organized by our national committee. We can go to the next slide.
Is it fine, or should I move to the next slide?
Yeah, you can move to the next slide, please.
Maybe the one before.
Can you move to the next slide, please?
Okay. Can you still see my screen, or is it kind of frozen?
I can see it, but it's on the third slide. It's still.
Okay. I'm sorry for that.
Yeah, maybe.
I think that's the challenge when it comes to the webinars. And when everything depends on the technologies, I will just share my screen again.
Yeah, no worries.
It should be fine, hopefully, this time.
Yes, it is. Okay, great. So, what's next? We will continue with these specific projects and expand both our community, our collaboration, and the type of projects in both in Romania and internationally. That's why we already have planned a few other initiatives, such as a joint webinar that comes next with NG in Canada, also a project that is just starting at the international level, at the NGNIC, which will be called Present Me Your National Power System. You'll find out more about that. And on the last slide, it's a QR code through which we invite you all to scan it and connect with us on all our social media platforms, on Facebook, on LinkedIn, Instagram. Get in contact with us, and yeah, if you have any proposals of
So
future
please,
collaboration, go ahead.
you can. Sorry for that. I think it should be fine now.
This would be it in few words about Romanian Energy National Committee. I think we can move further with our agenda. Thank you.
Thank you very much, Bogdan. Please subscribe and scan the QR code to get all the news, what the NG in Romania is doing. So thank you once again. And now I will very briefly introduce you about the CIGRE NG in Georgia and our activities. So I will make it very brief and on point to move to the final presentations part. So hello, everyone, and welcome once again. I am Pikria Elizarashvili, and I'm the chair of CIGRE Georgia Next Generation Network. So our engine section was established in 2022, so we are still quite young. Today, we represent up to 30 young professionals in Georgian power system, coming from 4 largest companies in the sector. Our members are actively involved in CIGRE's global activities. We are contributing into 6 study committees as regular or engine members, and with contributions to over 10 working groups. We always try to share our experience to support the energy transition and to get connected with other young professionals globally. So our members always contribute to some of the key highlight events of the CIGRE, such as the Paris session, CERC conferences, and CIGRE symposia. So this year, there is an upcoming CERC conference. So CERC stands for Southeast European Regional Council, which will be in the beginning of June. And our NGN members have 10 papers submitted for this conference. And I think this really shows the commitment from our side to get involved into the energy transition and to make connections within the CIGRE community. Looking ahead, CIGRE Georgia is committed to expand its memberships, and our key focus area is Georgian universities, because we would like to have more engagement from academia. For this reason, we plan to have student visits for the hands-on experience to the different substations, or this might be sometimes power plants. We plan to promote CIGRE by going to universities and providing presentations and spreading the information about CIGRE. And there are some technical workshops and high-profile webinars in our pipeline planned. And also our NGN section is supporting the establishment of Romanian energy in Georgia, which I think would be one of the highlights as well for our national committee. And I would like to make a short announcement at the end of my presentation. In the beginning of July, CIGRE Georgia is planning to organize a workshop in Georgia related to electromagnetic transit simulation. So it will be about EMT modeling and analysis. And I will share the information about this upcoming event in the upcoming weeks. So hopefully, if it will be interesting for you, you might come in Georgia and join. So thank you for your attention. And now I think it would be better if we move to the main presentations part. So as you already know, our today's webinar is about the connectivity resilience at the upcoming Black Sea submarine cable connection between Romania and Georgia. And I would like to take this moment to thank our esteemed speakers. I would like to thank Adrian Constantine, who is a shift lead dispatcher at the National Dispatching Center of Romania. He has more than 12 years of experience in power systems engineering and will be sharing some of the interesting insights from Romanian power system. We have Georgi Vakhnagadze, who is an head of strategic development department and Georgian State Electrosystem. He has more than 15 years of experience in the electrical power system planning, and he will be sharing some of the insights from Georgian power systems. So hopefully these presentations will give you some of the very interesting and promising insights. So Adrian, please, the floor is yours, and I will share your presentation in a moment.
Thank you, Pigria. If it's fine, I can share my screen. I think it will be able to have the presentation. Is this fine?
Yes, I think it should come in a minute. Can you see my screen?
Is it fine if I share the screen with the presentation? Can you hear me?
Yes, I can hear you. So just let me know when I should switch the slides.
I would like to share the screen if it's fine.
Okay, yes,
Great.
that should be perfect. You can go ahead, please.
Good. Let me know when you can see my screen.
Yes, please. I think it's fine.
Good. Thank you. So, good morning or good afternoon, colleagues. As Speaker mentioned, my name is Adrian. I work as a shift lead dispatcher at Transelectric. I'm a power system engineer, and in the next slides, I will be presenting you a couple points related to our system. Mainly, I'll describe you the current state of our power system, then a few words about some operational insights and the next plans that we have. We will be touching the importance of the interconnectors, and to close my presentation, I'll be sharing with you some insights related to the HVDC Link cable between Romania and Georgia. Good. To start with the current state of the Romanian power system. So, yeah, the grid of Romania is part of the grid of the continental Europe, meaning that the synchronous area extends from Portugal up to the eastern part of Turkey, including now Ukraine and the Baltic states. The system is quite wide and spread, as you can see, up to approximately 500,000 megawatt. And from this huge system, our system has a network up to 9,000 kilometer. We operate the 400 and 220 kV voltages. We have 82 substations, 11 interconnectors, a peak electricity demand that can reach up to 10,000 megawatt, and a capex plan for the next 10 years of approximately 2,000 million. Related to our grid, basically this is the transmission network of Romania. We operate fully this transmission network. You can see with red lines, this is the 400 kV transmission grid, and with green lines, you see the 220 kV transmission grid. Related to our capacities, we can reach up to 3,000 up to 4,000 megawatt of capacity through our interconnectors with our neighbors. And you see the split on each profile or on each border. We can reach up to 1,800 megawatt with Bulgaria, 1,000 with Hungary, 500 with Serbia, and 250 with Ukraine and Moldova. Related with the generation and the load mix, for 2023, we had approximately 16.5 terawatt hour, 30% of our consumption of the generation, sorry, coming from the thermal power plant. Here we include coal and gas. Approximately 20% coming from the nuclear power plant that we have in Chernavo, the 33% coming from hydro, and 17% coming from RES. And as you can see here, in 2023, we were a net exporter. The difference between exports and imports was approximately 3 terawatt hour. From the installed capacity perspective, we have approximately 18.6 gigawatt of installed power. We can see a high increase from year to year in the renewable energy sources, more specifically in the wind PV power plants. Wind is quite stable, but nowadays we see a huge increase in the PV, and the thermal and hydro and nuclear stays approximately the same. We don't have any changes here. Huge topic which is nowadays discussed in our country is the evolution of the installed capacity at consumers level. Here we discuss about the PV panels installed on the home end users. And here we can see a huge development. So if we would check, starting with 2022, we had, for example, January 88 megawatt installed. 2023 went up to almost 500 megawatt. Last year we had 1,500, and this year in January 2,400 megawatt. So the increase is quite high. And it is causing us quite some issues in the operation of the power system, but this will be discussed later, of course. Related to the impact of the prosumers, I just wanted to present you 4 days from April last year. Basically, there are 4 consecutive days which were quite characteristics for our system. With red, you can see the curve when we had the average temperature of 27 degrees and the cloud coverage is low. You can see how the curve is going quite down during the valley of the day. The consumption here is 5,500 megawatt, and of course this is about the vertical load, meaning that of course taking into account the prosumers, the load would be higher, but this is the load excluding the prosumers. Then if we have a look just at 2 days difference, the cloud coverage was really high, meaning that there was no PV infeed on the prosumers level. The average temperature, of course, was lower. And then you can see a huge difference of the load between the two curves, and it's up to 1,300 megawatt difference. And this is actually what the prosumers were producing on the 15th of April. Then you see here there was no prosumers production. So then the whole load of the prosumers was taken by the grid. So then the vertical load increased. Our average monthly consumption, we have the highest ones are during the winter. You see up to 7,500 megawatt. The lowest ones are during the spring. During the spring, we foresee the lowest consumptions in our grid, and also at the beginning of the autumn. The maximum hourly consumption, as specified, can reach up to 10,000 megawatt during the winter, and the lowest ones are during the spring and beginning of autumn. Good. Now, just a couple words about our plans for the future and some system operational insights. Following this, we will be discussing a little bit about some operational insights, the transit flows that we have through our grid, let's say the complexity that Ukraine synchronization brought us, small words regarding the voltage regulation during the off-peak and the imbalance regulation during the off-peak, and some plans and investments to mitigate some issues. Regarding the transit flows, Romania is quite interesting, situated at the interface between Southeast Europe and Central West Europe. Therefore, our grid sometimes is transited by flows. How is this happening? Basically, in the Southeast Europe, basically the grid of these TSOs, which are highlighted here. In this grids, the power produced is, of course, above the consumption from their grid. So then this part of Europe is exporting energy towards the Central Western Europe. So then inside of our grid, on top of the, let's say, natural flows to feed the grid in some parts of Romania, then we have overlapping transiting flows, which are going towards north and west. On the same time, we can have north to south flows. In this case, this area highlighted with blue is deficitary, meaning that it's importing power from the Central West Europe. This is also quite interesting because in this case, we have similar north to south flows, transiting flows, which are loading, let's say, a little bit more our internal grid. And it can cause some specific situations that we need to treat them operationally during the real-time operations. Regarding the voltage regulation, as you saw earlier, we have quite some power installed at the prosumers level. As mentioned, this is hiding the vertical load of the transmission grid, which is in the end causing low-loaded transmission lines. This low-loaded transmission lines are producing a lot of reactive power. In the end, we have an impact on the balance of the reactive power. So we end up with really low loads and quite high voltages. From the operational perspective, we are forced to take a lot of measures, and we prepare some specific schemes in order to cope with high voltages that we see during this period of year. I'll present you later that we also do some investments to mitigate these issues. But for now, it's quite a challenge. You see the off-peak last year during the Easter was almost 3,000 megawatt, considering the fact that the average load is 7,500, so it's even less than half of the average load. So to handle this operational constraints, we started to do some developments. first developments are trying to handle the issues that we encounter with the transiting flows. So we have a plan to move on with the 220 kV axis from porțile de Fier, Reșița, Timișoara, Săcălați, Arad to 400 kV. We plan to construct a new overhead line, double circuit, but just with one circuit equipped between Constanța Nord and Medgidia Sud. We plan to construct a new overhead line between Cădălin and Suceava and between Butinaș and Smârdan, and we plan to increase the transmission capacity for our 220 kV overhead lines by replacing the active conductor with some new one with increased section. And to cope with transit flows, we also plan to install dynamic line rating, and we have a great PMU implementation, the so-called National Synchrophasor platform. For the voltage regulation, we will be investing in new FACTS devices to compensate the reactive power, and the technology that was picked is actually STATCOM. And the implementation is ongoing. And if we would be to visualize this on our transmission grid, you can see with this magenta color, these are the new lines that I described earlier. This is the line Suceava, Gădălin, Butinaș, Smârdan. We have here the lines between Medgidia Sud and Constanța, the lines going from Cernavoda up to still Putelaj and Brașov. The 220 kV axis that will be replaced with the 400 kV axis here in the western part of Romania. STATCOM that will come in substation Sibiu Sud and in substation Bradu, which is here in this central part of Romania, and yeah, some oil lines or some other investments which are already built. Let's say is the 400 kV substation RF, which was created, and we have two new lines between Sibiu Sud RF and RF Țânțări. The importance of the regional interconnectors, as discussed, we have 11 interconnectors. You see them here highlighted on the profile. With Moldova, we have one interconnector, that is the line Isac-Cea-Vulcănești. On the profile with Bulgaria, we have 4 interconnectors, the line Medgidia Sud-Varna, Medgidia Sud-Dobruja, and the line Țânțăreni-Kozloduy circuit 1 and 2. On the profile with Serbia, 3 interconnectors, from which 2 of them are quite new. The new ones are Reșița-Pančevo circuits number 1 and 2, and the old one, which is in operation since a lot of years, is Porțile de Fier Gerdab. Here on the Hungarian border, we have 2 interconnectors, Arad-Chandrofalva and Dabeke-Shaba, and on the north, we have Roșior-Mukachevo. It's our Thai line towards Ukraine. What is interesting, though, to highlight is that Romania nowadays, it's at the intersection of the 2 capacity calculation regions. The continental Europe is split according to ACER methodologies and multiple capacity calculation regions. For each capacity calculation region, we compute the capacity on the interconnectors, which is given to the market. And I just want to highlight that now we have 2, but in the very next future, we will have in the end 4. So we will be at the interconnection of 4 capacity calculation regions, which is, let's say, quite challenging from the coordination of the capacity perspective. So this is something new that will come into the future. So let's see how it will go. From the importance of the regional interconnectors, of course, I just wanted to highlight 4 of them. There are multiple of them, but yeah, the security of supplies is one of the most important in case we have unavailabilities in our generation fleet. Of course, we can always import power from the neighbors. You saw that we can import up to 4,000 megawatt, which is yeah, more than enough, considering that power load is at 7.5 gigawatt, and yeah, we have a generation fleet of 19 gigawatt. So at any point in time we can assure our load without any issues. The renewable energy integration, another important point from the interconnectors perspective. Of course, when we have a lot of resin feed, some big chunk of it goes towards the export. So without having the amount of tie lines that we have, we will never be capable to integrate such a huge part of renewable energy in our system. From the balancing perspective and the structural changes of demand, of course, being connected into a 500,000 megawatt system, the trip of big generating unit is not really impacting the frequency. Therefore, from this perspective, being interconnected is a huge advantage. Also, we have international balancing platforms like balance netting ones and also some other ones which are coming into the future. This allows us to share balancing energy through the continental Europe grid. So it's a huge advantage from this perspective, from real-time operations. And last, but of course not least, the lowering of the energy bills. This is quite important because it gives us access to cheap energy. Of course, where cheap energy appears, then this allows the cheap energy to flow through the borders. And to exemplify this, I just want to show you one slide with the characteristic day in which we had almost a full price convergence across Europe. You can see, at least for the peak hours of the morning days, this is the core capacity calculation region. We have here the prices for Austria, Belgium, Czech Republic, Germany, France, Croatia, Hungary, Netherlands, Poland, Romania, Slovenia, and Slovakia. And you see that there are a bunch of hours when the prices were exactly the same in all the countries. From the capacity calculation perspective means that the borders were not congestion, so the energy could flow freely according to the wish of the traders, meaning that the prices were quite convergent. Good. Couple words related to the long-term vision for the power system development, Black Sea HVDC link between Romania and Georgia. The feasibility study that was done contains some technical data, and the technical data presented in the feasibility study, we identified that the technology that is feasible to be used is the VAC bipolar technology plus minus 525 kV voltage with electrodes. The maximum capacity is 1,500, but the recommendation would be to have an installed capacity of 1,300 megawatt. The total cable length, approximately 1,155 kilometers with a separate fiber optic cable, which would be installed. And the total investment would be up to 3.7 billion, from which 3.6 would be the construction of the HVDC link plus the converter stations, and almost 100 million for the separate fiber optics cable. Some key results from the study. According to the calculations, the HVDC link would be used up to 87.8% across the years. The direction of the power flow foreseen would be from the South Caucasus to the Southeast Europe. We will have quite a high share of renewable energy sources flowing from Georgia and Azerbaijan towards Southeast Europe, respectively to Romania. In this case, South Caucasus will act as exporter and Southeast Europe will act as importer. Of course, Romania will act further as a net exporter towards Europe. And this HVDC link would most likely reduce the renewable energy sources curtailment in South Caucasus. This would be more or less everything from my side. Now, if there are some questions, please just let me know. I'll stop the share screening and then we can discuss.
Thank you very much. Thank you, Adrian, for interesting presentation. So we have Q&A session at the end of the presentation, and now I will ask Georgi to share his screen. So, Georgi, the floor is yours.
Thank you, Pikria. Good morning, ladies and gentlemen. Please confirm if my presentation is visible now.
Yes, we can see it.
Great. My presentation actually is like Adrian's presentation detailed, but I will somehow try to manage to not to stress you, not to get you tired. So just basic context of that presentations, responsibilities and the role of the GSE for sure. We are the transmission system operator of Georgia. Main strategic document under which we are acting and operating and reinforcing our network. This is a 10-year network development plan. Also, the more information related to the Georgian power system, where we are, what we have, the current insights, and maybe also the challenges of our system, and why in that everyday operation to have this resilient network is the crucial and has the highest importance, and what we have in this regard also in GSE. Current visions and plans. For sure, also the regional interconnections for the increasing the power trades, for the increasing the green stability, and also the renewable integration towards the general the major mission to energy transition is absolutely important, and we are moving forward in this regard. And planning the lot of the projects there, doing the international cooperations and negotiations towards the respective stakeholders, respectively. And also all of this, if we form out what we will have in the next 10 years. As the long-term development, and this long-term development also includes definitely that implementation of Black Sea submarine cable, which will directly connect Georgia, but not only Georgia as a whole, the Caucasus region. Will have the unique possibility to start the direct trade, electricity trade with Europe, and this will be very beneficial and also the strategic important for the whole region, for the Caucasus as well as for the Europe. It will be a very important project after its implementation. So starting from that beginnings, the GSE, as I said, is a transmission system operator in electricity field, and as every TSO probably has the main missions to develop and operate the stable, reliable, cost-effective, and efficient transmission network. And what we are thinking about the stable and efficient and secure network is this, for sure, the security of supply of the transmission grid, reliability, power quality, voltage and frequency in that predetermined safe ranges. Also, to create the sufficient, to ensure the sufficient transmission network capacity in order to both integrate the generation and the demand objects, and in this regard, in this turn, to support the system development in the short, medium, and long term. and as well as not only for internal development, as well as for to create and to fully utilize that energy trade possibilities abroad to increase the interconnection and trade possibilities. And one of the major goal also while we are developing a network for the above mentioned purposes, also for sure integration and connection with TSO-s grid and integration to the TSO-s 10-year network development plan definitely is one of the major goals for GSE and for the Georgia as a whole, for sure. I will not stop in this slide for a long time. The 10-year plan is perfectly known for the Transelectrica, as for the NSOI member TSO is the main strategic plan in terms of the transmission network development for the 10-year horizon. And it's a time target program for the reinforcement of the grid and to create a secure network, to create reliable connections and to ensure the security of supply, as well as to increase that interconnection electricity trade possibilities. Our 10-year plan actually was developed in accordance and with the cooperation with TSO-s standards and TSO member state TSOs. And our plan, the legal basis of our plan is actually the acting law on energy and water supply, as well as acting network code in Georgia. As for the current situation, what we have nowadays, it's actually the main transmission network consists of the mainly 2x220 kV network, as well as 500 kV network. The purple lines and substation are of the 500 kV infrastructure. As for the 220 kV line, it's presented as the red lines and points for respectively for the lines of the substations. And besides that, the main lower voltage level we have in Georgia is 110 kV, but this is a small portion of transmission network. Generally, that level, that voltage level, that infrastructure is owned mainly in Georgia by the DSOs, distribution operators. There are two of them. So they are distributing the electricity, transferring from the transmission network of GSE towards their network, and they are distributing in this way to the end users the electricity. That's just main parameters, and the summary totals of our network is shown above on that slide above map, and also the current power exchange possibilities with neighboring power system states, as we have currently with Russia, with Azerbaijan, with Armenia, with Turkey. We have the connections with every neighboring bordering power system. And in some content, in some context, that exchange possibilities strong enough, connections are strong enough, but anyhow we are planning to reinforce that comparably weaker connections. For example, with Azerbaijan, we don't have any planned cross-border projects now so far. But we have some cooperations and negotiations because Azerbaijani party Nazar Energy has some visions, but currently we don't have any plan to reinforce cross-border projects with Azerbaijan. But except Azerbaijan, we have cross-border projects with any bordering country presented here that we are planning in next 10 years to reinforce that trade possibilities with them. As for the current generation facilities and objects, they are located, as you can see in the slide, throughout the whole country. As for the general share, biggest share comes from the hydros. We are hydro system, yes, near 75% of total installed capacity is coming from the hydros, general share of which is located in the west part of the power system. As you can see, the highest installed capacity stations are here in the west part. And besides hydros, we have the thermals near 1,200 megawatt, and also one and only one wind farm which is connected at the transmission level is the 21 megawatts. So both in terms of the annual generation and in terms of the installed capacities, hydro is dominant, definitely, in our system. And you can see in the previous slide also that our next 10-year plans won't change that situation much, but anyhow, that renewable share will increase, and you will see the specifically that estimate numbers, projected capacities. As for the 10-year statistics, you can see the evolution of generation and the consumption year by year, starting from the 2014, and you can see that they are very much in line with each other, but with a small portion that consumption is leading towards generation, and we have then implementing energy import from the neighboring power systems, both in the natural gas and in electricity. We have some predefined volumes which we need, and it's necessary to do import in order to cover increasing demand, and in this way, in order to ensure generation adequacy in the system and the security of supply as well. So that annual growth percentages is more or less the same for the generation in Georgia in the demand, but it depends on the specific year. It depends on the hydrology, definitely, and that proportion maybe will be somehow slightly changed, but anyhow, that increase percentages and the growth percentages is more or less the same for both the generation and the consumption. What we have the current challenges in our system, these are at least the major part of the bottlenecks and challenges presented here are regarding to the need of network reinforcement. Backing up that interconnection line, backing up some radial lines, and the lines who are in charge of transfer a bulk amount of electricity towards the bulk demand centers, and some portion of that lines are not sufficiently reserved. So we need, and we are planning, and these projects are including in our 10-year plan to reinforce that sections, and generally, and most importantly, to ensure fulfillment of -1 criteria throughout the whole transmission grid. So that's any outage of one of the any element in Georgia will not cause any congestion, any further worsening of the situation, and respectively some shedding of some generation and load, and in order to meet the balance. So fulfillment of the -1 criteria is absolutely important and major goal of the projects included in our 10-year plan. But besides transferring congestions, we have the low inertia. Our system wasn't designed in the origin to operate independently as its own. It was designed to operate with Russia, with the Azerbaijan in parallel synchronous mode. This is not the case nowadays. We have a synchronous connection with only one of them. And even in worst case, if we don't have any synchronous connections with them, with Azerbaijan and Russia, and we are operating in isolate mode, this creates also the challenges in terms of the inertia, because we are not a big system. Even comparing with the neighboring power systems, we are small nowadays, so that inertia is a challenge, definitely. And besides inertia, reserving capacities and respectively the system flexibility is also is need to be increased in the future, definitely. And specifically, if we are planning and we are planning to introduce the renewables, big portions of hydro and wind power plants in our system, that system flexibility should meet the requirements and needs for the future integration of renewable objects in Georgian power system. And one of the direction of challenges we face year by year, maybe not frequently, but anyhow, this is the case. Power system resilience should be also increased, and there are a couple of the examples in the events, maybe not again, not by each year, but in the previous years we had faced some problems arisen from that climate impact on the transmission infrastructure, and also with the cooperation of the CIGRE CIGRE, we have initiated that power system resilience study recently, and we are moving forward. This project is ongoing. We are also somehow reviewing and assessing that available methodologies for the other TSOs. And we are now in process of elaboration of power system resilience study for the Georgia. And the K climate changes, which will be definitely included throughout the assessment of that mentioned studies, the heavy snow and ice coverage and landslides and earthquakes and avalanches and so on, which are generally the reasons of that impact of our transmission system in the Georgia. And a couple of examples, not to spend much time on this, that this is an interconnection line with the Turkey existing line Meskheti, which was impacted and damaged in the 2017 due to the heavy snow. Also, another cross-border line towards Russia is the Caucasian, which also the same reasons, heavy snow and also the wind has damaged this line. This is a 400 kilometers long line. It goes to the very severe route and the harsh climate, and this line frequently lies under impact of climate change. So our respective departments, as well as the owners of these lines of Sakrus Energo company, doing their best to somehow manage in a time manner to restore normal operation of that cross-border line. Besides Caucasioni, also that more or less in the closer region of North Swaneti, Upper Swaneti, 110 kV line Ifari frequently is damaged due to heavy snow. This is our line, and our team, the team of GSC, doing their best for every event to speed up the recovery process and to timely put that line under operation again after that repairing the maintenance works. So again, that more or less the same reasons, ice coverage for that existing infrastructure of 220 kV line, Didgori line, as well as Koda line, located in the east part of the power system, near the border of to Armenia. As well as for the same region, the substation Marneuli and the power high voltage transformer was damaged to the hurricane and the ice coverage, and GSC had to replace the respective parts in the substation to ensure that our transformer is able to put in operation again. So these are the several examples, and the study should investigate what could be that optimal measures in order to increase our system's resilience. And finally, the general goal is definitely to ensure security of supply and minimize the interruptions and energy not supplied in our system. Again, that's another. Then I think it's the last case in form of slide. This was the actually in the previous month, in the February month, very high snowfall in the specifically in the west part of the Georgia, and the main region which was impacted was the Guria region. But our transmission network wasn't put under any serious risk, and it remained resilient, and its operation was continued without any interruption. So it was some positive outcome for the GSE, and not only for GSE, for the transmission network of Georgia in those cases. As for the blackouts, let's say the couple of words in our system. As you can see, starting from the introduction of remedial action scheme and anti-emergency automatic in our system, that number of the partial and total outages, brownouts and blackouts are comparably decreasing year by year. You can see that decrement on that slide. And also for the number of the savings from the breakout and the brownouts by the remedial action schemes, you can see also the summary numbers. So year by year, this automatic is really protecting our system, that we are very proud that they are existing and they are acting effectively in our system, and also that system is also expanding, and it becomes better, and it becomes and it protects further in our power system, so that it prevents that any serious emergency will have some big impact on uninterruptible operation of our power system. As for the 10-year plans, as I said before, on the left side you can see the existing generation portfolio, and then the right side we have that visions and plans included in our 10-year plan, what we will have in next 10 years if we implement all of the projects, the hydros, wind and solar, the thermal as well in our power system, so that our power system will be near tripled in next 10 years if everything will be implemented. And actually we are planning our reinforcement, our transmission network reinforcement based on that case, that to fully give possibilities of integration of everything which is planned under one 10-year plan. So step by step, if we can see something about the generation connection possibilities, is presented here. So in the short term, we are planning to introduce the transmission connected battery energy storage system, which will be first project for the Georgia. It will give possibilities to integrate nearly 1,000 to 1,500 megawatts of generation in the new generation for the system. And as we move forward, besides beyond that battery energy system, for the 2034, we have near 8,000 megawatts of generation sources, and this is a summer total installed capacity of the projects. From which that big share of nearly half is coming from the wind and solar power plant projects. For the forecasted energy balances throughout the years, for the main scenario, optimistic development of the power system is shown here. As you can see, year by year, our export potential goes higher due to the integration of big part of the generation projects in our system. And again, that integration of that renewable energy creates the necessity to increase also the power system flexibility. And one of the solutions, as I mentioned, is the installation of battery energy storage systems in our transmission grid. Also, if that development will not will go other than that optimistic case, we have also the alternative scenarios of generation, the demand evolution, and respectively the differences between them in terms of the electricity balances is shown here. As for the supporting mechanism from the GSC towards the renewable energy sources integration, beyond that battery energy storage systems, we are working closely with the ministries for the implementation of the reservoir storage HPPs. Also, the pumped storage power plant is under consideration, and for the biggest capacity power plants of RES, renewable energy sources, we are collaborating with them, and for one of them, for 550 megawatt solar projects, the outcome was that it will include that 250 megawatts of batteries to balance this variation in generation output and somehow to support system for the further integration of the new renewables in our system. For the summary capacities towards the solar and the wind energy projects, you can see here that location as well as the summary capacities. For the upcoming projects, near 2,000 megawatts each for the solar and wind is expecting, and these capacities are included in our 10-year plan. But with the yellow background, you can see the numbers, total numbers of installed capacities on which we have already granted the connection request, and the respective agreement has been signed with them. So they are expected also to be included in our next 10-year plan, and respectively transmission network reinforcements maybe will be reviewed, and also some other projects will be included in our 10-year plan. More on that supporting of the renewable energy. This is actually the measures from the ministries. The respectively renewables auction based on the CFD mechanism has been conducted recently in 2023. First auction, also second auction, and summer install capacities can be seen on the bottom part of that slide. Data auctions included everything besides thermal, HPPs, wind and solar, and the respective amounts for each projects. And also the third auction is upcoming and expecting to be assessed that connection applications, not connection, but applications for the participation of the auctions has been also received in the ministry. And just for the summary numbers, you can see here that these capacities are enormous for our systems. Now ministry is actively working on that assessing of the applications, and some part of that installed capacities will move forward to the next stage towards signing of respective agreements for this support. For the main projects of our 10-year plan, to divide interconnections, this is left side, and the main internal system projects are shown from on the right side. Integration of the generation, ensuring of security of supply, and ensuring of connection of new demand facilities are these are the main goals, which are for which are those projects designed and included in our 10-year plan, as well as the battery energy storage system, as I mentioned, will be connected in the transmission level and will ensure that the power system stability and flexibility will be increased. Just as general values and the numbers, which will be result of implementation of our 10-year plan in the construction of the every transmission projects. So as for the substation, those are the 70 substation. As for the transmission lines, the 23 lines will be constructed. I have already mentioned the energy storage battery. And the estimated investments for all of these projects are near 2.3 billion euros. And this infrastructure will create a possibility to integrate and connect more than 300 new generation power plant with installed capacities of beyond 8,000 megawatt, as I said before. And as a result, this map shows every project, and actually that our transmission network in next 10 years, by the 2030 to 43, we will have strong enough transmission grid, and besides the internal grid reinforcements, we will reinforce also the cross-border connections towards our neighboring power systems, and another corridor which will be created will be the Black Sea submarine cable, as my colleague already mentioned, and I will somehow add several words that this is an interconnection project between the Georgian and the Romanian power system. This will give opportunity to Georgia to implement electricity trade, and not only Georgia but for the whole Caucasus with the European countries. And the project will assist in energy security of European Union Caucasus region, and will definitely support development of renewable energy sector. And as for that specific steps and the tasks, feasibility study is already completed previous year by Italian consulting company CESI. Also, environmental and social background review report is already completed. And there are also planned some further steps, surveys and geophysical and geotechnical surveys for the in order to in the future to start this future physical implementation of this project. Moreover, on this project, I will add also a couple of words. This is already included in ENTSO-s 10-year plan, starting from the 2022 version. It was also in 2024, and we are now in process, and we will start working on the inclusion of these projects in next 2026 versions of ENTSO-s 10-year plan. Thank you. That was all from my side for your engagement, and feel free to send the questions and pronounce it. Thanks.
Thank you very much, Georgi. And once again, thank you, Adrian, for your presentations. Now we can move into the Q&A session, and I would like to remind our participants that you can send questions in the chat, or you can directly turn on your microphones and ask the questions. And as I see, we already have a couple of questions in the chat. So the first question is to Georgi. How come you had a significantly lower consumption in 2023 and could export energy, whereas you imported 2022 and 2024? I think this goes back to the statistics you had in the presentation.
Yes, actually, that period was also characterized with the increase of the export. This was actually the biggest, one of the biggest role in that export capacities was coming from that transit from Azerbaijan. that was a period when Turkey demanded that import capacities to be increased, and that was the reason why that we had that high amount of export. But besides as Azerbaijan, also there are the several periods throughout the year for Georgia where we have generation excess, especially starting from the April month up to the July maybe. That generation excess mainly goes to the Turkish power systems, but in those mentioned period in 2022 and maybe more beyond 22, Azerbaijan transit was added to our excess, so that was the reason of increase of export.
Thank you. There was another question related if we would share the presentation. So I will ask about this, our speakers at first, but we will definitely share the recording of the webinar so you could have a look at the presentations. And the second question is also to Georgi. So the question is, in the current generation facilities slide, what does regulated 2,387 megawatt represent? In Georgia, do producers have prices regulated by the regulator, or what does it refer to?
Here, that regulating HPPs actually mean the storage HPPs, which have water reservoir, and we store that water and using it as it is needed throughout the regimes and scenarios of the year. Yes, prices of the generation facilities are completely regulated and under the respective rules of regulatory commission acting. In Georgia, GNERC is the respective body which regulates and defines the tariffs for each generation object in Georgia.
Thank you. Is there any other questions? So there is one more question. What is the status of the HVDC project? I think they mean the Black Sea submarine cable in this case. Well, as far as I'm aware, the project is now under the seabed investigation phase, but please, Georgi and Adrian, correct me if I'm wrong.
Oh, no, that's totally true. So basically, the feasibility study is being finished, and as you said, now we are running the seabed studies.
Thank you. Do we have any other questions? If not, maybe I will use this opportunity to ask a question to Adrian. So I see you mentioned Romania is connected with continental Europe. So what do you consider as a biggest challenge in terms of operating and dispatching the interconnected power system?
Yes, basically the biggest challenge, as I mentioned, is more or less related to the transit flows that are appearing through our grid. This is why we need also to make our grid available for these transiting flows, meaning that on top of the natural flows that we have on our transmission grid, then we have, let's say, loop flows or transiting flows from the other TSOs. This is one of the biggest challenges that we have nowadays. But I must admit that the advantages are way above the challenges that we have now. So yeah. Bikria, I'm not sure if it was just on my side, but I could not hear anything from what you have asked.
Yes, so there was a question related if there is any website for public information regarding the HVDC link. I think there should be a website, or you will share it in the chat.
Yes, I will share that specific link from our GSS website. But besides GSE, also maybe some publicly available data will be at the TSO-s portal on the projects included in their 10-year plan. So Lexi submarine cable is a part of that plan. I will share our link and also try to get that link maybe in a slightly later stage from the TSO-s portal. Thank you.
Is there any other questions? Maybe in the meanwhile, I also have a second question with Adrian. I think I saw somewhere on your presentation slide about the dynamic line routing, so I wonder if it is in the pipeline for the future to be implemented in Romanian power system.
Pikaria, your sound it's still not functioning properly, but I guess you are
Sorry.
wrapping up everything.
Can you hear me now?
We can, but yeah, the sound is very low, and
Okay, sorry for that.
I think it's fine. I can moderate it further from this point. So I'm looking on the chat. I see that Georgi has already added the link with more details about the HVDC link that Katalin has asked in the chat. If there are any further questions, we still have some time for further questions to add here in the chat, and take the opportunity that we have our speakers online. Okay, if not, we will end our webinar here. We would like to thank, in the name of both NGN Georgia and NGN Romania, to our speakers for accepting our invitation and presenting all these very relevant insights from both the Georgian and Romanian power systems. We hope that it was helpful. We want to thank all the participants that took the time to connect, and we invite you to follow us on social media because we will plan to organize new similar webinars on different topics. And if you remember, in the registration form, you also had one of the questions: what are your proposals for new topics? We will take into considerations that, and we will organize new webinars depending on your requests. And we wish you all a pleasant rest of the day, and we hope to see you soon in different CIGRE activities, online or physical. Thank you to everyone. Bye bye.
Thank you, Bogdan. Thank you all.
Thank you. Bye.
Today's webinar. Thanks to our
Thank you. Goodbye.
Goodbye.
Goodbye.